Yes. Investigate what problem is solved by the function phi is equal to minus f by d cube xy square into 3d minus 2y. Apply to the region on y is equal to 0, y is equal to d, x is equal to 0, on the side x positive. So this is a two-dimensional Cartesian coordinate problem. So normally when such types of problems are given, they will give the stress function. Phi function they will give. So already satisfied that biharmonic equation. So in this problem, phi is equal to minus f by d cube x into y square into 3d minus 2y. So this is the given stress function. The question is, what problem is solved means we have to find out the sigma x, sigma y, tau x, and we have to sketch the distribution of this. So we have to sketch the stress distribution. That is the main problem. So you know that in elasticity you have one-dimensional problem, two-dimensional problem, three-dimensional problem like that. Of course, it's a two-dimensional problem. He has given the boundaries here. He has given the boundaries for x and y. So x can vary from 0 to L you can take, because x side positive means 0 to L you can take. Y varies from 0 to D. So that is the meaning. That means if you take x axis like this and y axis like this, if you take an element, that element length will be, suppose this is the origin 0 0, this will be your y axis, this will be your x axis. So x is 0 here, x is equal to L here. The distance between these three is here. Correct? That is the meaning of this. X positive means this side we are taking. So x positive means you can take this is equal to L. Then y is 0 here and y is D. So D is the dimension in y direction. L is the dimension in the x. So it's a two-dimensional element. So on this element, we need to find the stress distribution. So at this point, what is the stress? At this point, what is the stress? Here, what is the stress? Here, what is the stress? Middle, what is the stress? Like that. So there are three types of stresses here. We know that the three types of stresses are sigma x, it will be like this. Sigma y will be like this. And tau xy, something like this. Tau xy. Just I will show how they will act. This is stress. This I have explained. It's a two-dimensional stress system. In a two-dimensional stress system, three stresses will be there. Sigma x in x direction, sigma y in y direction, tau xy is the shear stress. So tau xy will be acting in all the four cases. Correct? So if tau xy is like this on the upper face, it will be in the opposite direction of the lower face. Similarly here, these two should join here. So here it will be downwards, here it will be upwards, like that. So three stresses will be there. So now the question here is, we have to plot the stress distribution for this element, given this stress function. Here F is constant, D is constant, because D is the dimension in y direction, L is constant. So F, D, L they are constant. F is nothing but a force there. This is a constant value. F, D, L are constants. So only x and y are the variables. Now we know that in the case of a two-dimensional stress system, the formula for stress components in terms of phi. So this we have done already. First one is sigma x. How do you get sigma x knowing phi? What is the formula to find sigma x? Sigma x is dou square phi by dou y square. You have to remember that. This is sigma y. sigma x. Second one, sigma y is given by dou square phi by dou x square. Third one, dou x square. What is the formula? Minus dou square phi by dou x square. So since you know the function phi, you have to differentiate and get the stress components. First one, let us find out sigma. So if you want sigma x, I have to differentiate this phi 2 times. Otherwise, you just find out all the derivatives, then you can substitute. So what is dou phi by dou x? Dou phi by dou x ಏನಾಗುತ್ತೆ? This f and d constants. Please note that. ಇದರ ಬಗ್ಗೆ split ಮಾಡ್ಕೊಳ್ಳಿ. You can split this into phi can be written like this. I will just split this phi. Phi you can separate the terms. Minus ಏನಾಗುತ್ತೆ? 3f by d square ಆಯ್ತಾ? d and d will cancel. 3f by d square xy square. First term. Second term minus into minus plus ಆಗುತ್ತೆ. 2f divided by dq. 2f divided by dq into xy cube. Correct? Is it correct? Just I have separated these two terms. Minus 3f by d square into xy square plus minus into minus plus 2 times f divided by dq into xy cube. Correct? I have just multiplied 2 terms ಮಾಡ್ಕೊಂಡಿದ್ದೀನಿ. Now let us differentiate this with respect to x partially. When you are differentiating with respect to x partially, y becomes constant. So our idea is that minus 3f by d square into y square into derivative of x is 1 plus 2f by d cube into y cube. This becomes constant. Derivative of x is what is? ಸರಿಯಲ್ವಾ? ಮತ್ತೆ ಡಿಫರೆನ್ಷಿಯೇಟ್ ಮಾಡಬೇಕು. d square phi by dx square. Second derivative. ಇವಾಗ ಏನಾಗುತ್ತೆ? ಸೆಕೆಂಡ್ ಡೆರಿವೇಟಿವ್ ನೆಗೆಟಿವ್ is actually zero ಆಗುತ್ತೆ. ಯಾಕೆ? there is no x term here, there is no x term here, it becomes 0. Dou square phi by dou x square will be 0. First one. Next term, differentiate this phi with respect to y now. Dou phi by dou y now. This one. We are differentiating with respect to y. We have to treat x as constant. Minus 3f by d square x is constant into 2y. Correct? So 2y is 6. So minus 6f. 3 into 2 is 6f. Divided by d square into xy. Correct? X into 2y. Then 2 I have multiplied by 3 becomes 6. So that is the first term. Plus second term becomes differentiating with respect to y. 2f by d cube. 2f by d cube into x becomes constant. 2f by d cube into x becomes constant into 3y square. Alva? How is that? 6 into y square. And 10 in y square. Correct? Next, once again differentiate with respect to y. You get dou square phi by dou y square. So here it becomes minus 6f by d square into x ಬರುತ್ತೆ plus here 2y ಆಗುತ್ತೆ ಅಂದರೆ 12f by d cube into x square. So here please note that it is not 0. ಇಲ್ಲಿ 0 ಬರುತ್ತೆ. ಇಲ್ಲಿ 0 ಇದೆ. Next ಇನ್ನೊಂದು ಬೇಕು ನಮಗೆ. One more derivative I need. So what I will do? So dou phi by dou x I have here. So we know that dou phi by dou x is equal to minus 3f by d square y square plus 2f by d cube into y cube. I will differentiate this with respect to y now. So we will get dou square phi by dou x dou y. I need this, you know. With respect to y, you have to differentiate this one. So this becomes 2y. So minus 6f by d square into y This becomes 3y square. 3 into 2 6. 6f by d cube. Got it? This is what you get. Now, once you get these derivatives, you can write now sigma x, sigma y, dou x. So therefore, sigma x is equal to dou square phi by dou y square, which is this minus 6f by d square x plus 12f by d cube xy. This is sigma x. It is a function of x and y. Sigma y will be dou square phi by dou x square, which is 0. There is no sigma y here. There is no stress in y direction. That is the name. Next, dou xy is minus of dou square phi by dou x dou y. So dou square phi by dou x dou y is this. So minus of these things, this becomes plus, this becomes minus. 6f by d square, minus 6f by d cube. 6f by d square y minus 6f by d cube y square. So these are the stress functions. So first step, we have to differentiate that phi with respect to x twice, with respect to y twice, then once with respect to x, once with respect to y, you will get the stress components. So this is first step. So we got the expressions now. From the expressions, we can sketch the stress distribution by taking the element like this. Now the next question is how to sketch the stress distribution in that boundary. So stress distribution. So all the three stress distribution we have to make, out of which one stress is 0. Which one is 0? Which is 0? Sigma y. So there is no stress in y direction. The meaning of this is no stress in y direction. So you need not sketch that. But you have stresses in x direction as well as shear direction. You have to understand. Similar Berkowitz. Understand and write. Yes. That means we have to plot these two now. Sigma x and dou x. We have to plot sigma x. There diagram. So we know that this is the element. Now I will write the element now. So let me take these points as ABCD. Now ABCD is the element. So I have taken x here, x axis like this, y axis like this. We know that this is D and this is H. This is your orbit. 0, 0. So coordinates of A is 0, 0. X is 0, y is 0. Now can you tell me what are the coordinates of BCD? You know the values of x and y. What are the coordinates of B? Simple is it? Coordinates of B are like that. What is the value of x here? L. What is the value of y?
0.
This seems to be knowing that. Then, what are the coordinates of C?
X and D.
Is it 0? Correct. Along y axis x is 0, along x axis y is 0. And now we have to plot the sigma x in along this boundaries. So what we have to do here is we have to write down the values of sigma x and tau xy at these 4 points. ಈಗ ಒಂದು ಟ್ಯಾಬ್ಲೆಟ್ ಕಾಲಮ್ ಮಾಡ್ಕೊಳ್ಳೋಣ. We will have a tabular column. So I write the tabular column now. 4 points. I need the values of sigma x and tau xy at 4 points. Just substitute the values of x and y and get the values of sigma x and tau xy. So it's our tablet here. Point sigma x tau xy. You need not write sigma y because anyway, but all the points of the on the element sigma y is 0. Only these two. What are the points now? Point A 0, 0. You substitute x is equal to 0, y is equal to 0 here in this. Correct? Sigma x value 0. Just go and substitute. Tau xy. Put x is equal to 0, y is equal to 0. This also becomes 0. Next. At point B. B is L comma 0. Put x is equal to L, y is equal to 0 in this. It's 0 on it must answer. Minus 6f by d square L. Correct? Next, tau xy. Here, put x is equal to L, y is equal to 0 means 0 answer. Next, C. At C, you have L and D. X is equal to L, y is equal to D. X is equal to L andre ಇಲ್ಲಿ L ಬರುತ್ತೆ, y is equal to D ಅಂದ್ರೆ D ಬರುತ್ತೆ. So both the values will be there. Correct? You will have both the terms will be there. So minus 6f by D square into L plus 12f by D cube into L into D. Simplify what it is. You can simplify this. Minus 6fl by d square plus inverse 12fl by d square. Correct? 1d will get cancelled, no? What is this? 6fl by d square. Got it? That is the value. Next, at this point, at the same point L comma D, what is the value of tau xy? So put x is equal to L, y is equal to D. Of course, here there is no x term. We have only y term. So it will be 6f d square. 6f d square into D minus 6f d cube into d square. I think it will become 0.
No sir. 1d.
6f by D minus
6f by D. 6f by D.
No, 0 alpha. That's what I said. 0 alpha. It becomes 0. Just substitute more values. Next D. Point D you have 0 comma D. Put x is equal to 0, y is equal to D. Put x is equal to 0, y is equal to D. In this 0 alpha. This one. Put x is equal to 0, y is equal to D means? No, it cannot be 0. X is 0. Y is D.
Same.
Yeah, you will get same. Because 0 na? 6f by d square into D. Correct. Minus 6f by d cube into d square. So it becomes 0. Now the thing is, we have got the values at 4 points. But it is not enough. To sketch the stress distribution, we require the stress values at some more points also. That more points means normally what we do is we will calculate at the midpoints. Midpoints also. Midpoint at the E by 2, F, G, H. ಅಥವಾ ಅಟ್ಲೀಸ್ಟ್ ಇಲ್ಲಿ ಬೇಡ ಅಂದರೆ ಇವೆರಡು ಪಾಯಿಂಟ್ ಎಲ್ಲಾದರೂ ಮಾಡಿ ಅಲ್ವಾ ಇಲ್ಲಿ in all points are model. Because now exact distribution you can get. Only at corner points not sufficient. So what are the coordinates of this? This is L by 2 comma 0. This is L comma D by 2. This is L by 2 comma D. This is 0 comma D by 2. Correct? Now let us calculate these stress values at those 4 points also. So continue. E is L by 2 comma 0. Put x is equal to L by 2, y is equal to 0. You will get sigma x. So the second term becomes 0, first term only will be there. Minus 6f by d square, minus 6f by d square into L by 2. That's all. That is minus 3fl by d square. Correct? Huh? Okay? Not yet. You just continue with that substitution and simplification. So, tau xy means in this we have to put y is equal to 0, x is equal to L by 2. That means it is 0 only. There is no extra there. Continue this now. At other 2 points also. 3 points. E and F, G, H. At those 3 points also. So totally we will have in 8 points. So here so this is sigma x, this is tau x. F is here L comma D by 2. L comma D by 2. Yeah. What is the value of sigma x? X you have to put L, y you have to put D by 2. So minus 6f by d square into L plus 12f by dq into L into d by 2. So that is what we will get. अच्छा तो व्हाट हो गया स्टेप nothing special. You go on doing like this. Just simplify this. What you will get, you write. So if you simplify this, minus 6fl by d square plus 1d will get cancelled, 6fl by d square l. So it becomes 0. See? Correct? What will you do? You have to do it. Do it. Tell me that value, tau x value. Substitute for x as L, y as d by 2 in this. 6f by d square into d by 2 minus 6f by d cube into d by 2 square means d square by 4. This is what you will do. So here it becomes 3f by d minus 3f by 2d. 3f by d minus 3f by 2d, which you will get 3f by 2d. 3f by 2. Next at G, L by 2 comma D. Put x is equal to L by 2, y is equal to D. So what is that you are going to get? X is equal to L by 2, y is equal to D. So minus 6f by d square into L by 2 plus 12f by d cube into L by 2 into d, x into y. Yes, this will be now minus 6fl by 2d square plus 6fl by 2d square. So that will be 0. Some of the terms become 0. So it will be
3fl by 2d square minus 3.
which one?
Okay.
Minus 3fl by d square plus 6fl by d square. That means it is 3fl by d square. 6fl by 2d square d square. Yeah, 3fl by d square. Next, tau xy. Put x is equal to L by 2, y is equal to d. So there is no x term, only y term. 6f by d square into d minus 6f by d cube into d square. Here we get 6f by d minus 6f by d, which is 0. Next, lastly, h 0 comma d by 2. 0 comma d by 2. Put x is equal to 0 means first this becomes 0. Correct?
Yes.
In here, only y value have to put or d by 2. So 6f by d square.
F by F main F by the same. So d by 2.
Put x is equal to y is equal to d by 2. What is that?
So no sir, I'm telling that's the same value, table first element, same value will come. There also be substituted d by 2. Next one.
There's only y term, sir.
But here, only y term here.
Y term.
Sorry, sir. That is all. So it will be getting 3f by correct?
Yes, sir.
Oh, now these are the values. So these values you have to show on the diagram. And you have values on the key values. Zero, 0, value. Then here 0, here this value, 0, this value. Now let us see how we can represent them in that line. So you know all the values now. We have to represent sigma x and tau xy only because sigma y is 0 at all the points. There is no normal stress sigma y at all the points. So first one by one we will take up. First point A. First I will plot sigma x now. Sigma x acts in this direction. Please note that. So anyway you can write in two diagrams also. So sigma x always acts like this. This is how sigma x acts. One by one we will take up. Sigma x. At point A, what is the value of sigma x? 0. Correct? We have to see these values now. At point A, 0, being only minus 6f by d square L. It's a constant of course. Minus means it is compression. Please note that. Positive value, tension. You just remember this. So you are getting 0 here at point A, but at point B you are getting negative value here. Okay. What is the value? 6f by d square L. Now how to show that I will show you. You just write like this. It shows compression, correct? What is the value of this?
Minus
6 minus beta. If you write like this, it is understood. 6 only magnitude you write. 6 of L by d square. So this is the sigma x value at B. Next at C, 6 of L by d square. Same value, but it is tension.
tension.
ಅರ್ಥ ಆಗ್ತಿದೆಯಾ? ಟೆನ್ಷನ್ ಅಂದರೆ ಸಿ ನ ಟೆನ್ಷನ್ ಅಂದರೆ ಹೆಂಗೆ ತೋರಿಸ್ಬೇಕು ನಾವು ಅಷ್ಟೇ 6 Fl. Next D, it is 0, nothing to worry. E, it is minus 3Fl by D square, means half of this one. This 6Fl, you know, half of this but compression. So minus, so here it is compression. ಇಲ್ಲಿ compression ಆಯ್ತು.
arrow mark ತೋರಿಸೋದು
So what is the value of this? 3 Fl by D square is compression. Next, I will go to F, 0, nothing to show. G, 3 Fl by D square, so same value but it is tension. 3 Fl by D square, correct? Antalva? So all the at H it is 0, but ಅಂದರೆ ಈ ಕಡೆ ಏನು ಇಲ್ಲ ಅಂತ ಇದೆ. There is no sigma x value on this edge because on the standard edge x is 0. Since x is 0, this is the on y axis x is equal to 0, no sigma x on this face. So no sigma x on face AB on AD plane. Now I have one question. What is the value of sigma x here? F1 is 0 alva? F1 is 0 tane? Yeah, F1 is 0. So what is the value? That means here it is 0. Here it is 0. Now what are the values of sigma x from here to here? Can you imagine how it will be? ಇಲ್ಲಿಂದ ಇಲ್ಲಿಗೆ ಹೇಗಿರುತ್ತೆ ಅಂತ C in the F here. See, here it is compression, here it is tension, here it is 0 on this face. Then how it varies here, here, here? Can you tell me?
You have to divide
How it varies? For that what you have to do is, you have to see this equation. Sigma x equation contains x term and xy term. Xy means it is curve. If it is only x, then it is straight line. Here it is curve. Curve means since here it is 0, what I can write here is, I can just draw like this. Draw a curve here. It's a smooth curve. Like this. So from here to here, completely it is tension. Next, from here to here also it is curve, but the thing is it is compression. It is like this. So this is also curve, compression. Here it is tension. So we cannot put all the values. So what we do is, we take only corner points and midpoints. There we will find the values of the stress components and then we are going to plot. On similar lines, you can show here also but not required. This is also process. That is enough. Yes, that is about sigma x. Now I want to show tau xy also. Both the stresses we have to show in a diagram. So your sigma x diagram, now it is like this. Sigma x diagram is like this now. So it is curve, then curve. Thing is, it is like this. Got it? This is your sigma x. Value 0. This is 6 Fl by d square. This is also 6 Fl by d square. That is 0. So this is B. This is F. This is similar lines. We have to plot tau xy. So please note that in tau xy, It contains y and y square term. Y square means it is parabola. Y square is equal to 4ax. That's equation. No? Square is a parabola. This is one curve, xy. xy is a curve. Let us not go in detail about all those mathematical things. Only we have to show that it is a curve. Now we will plot the tau xy now. We will have one more element like this. Don't plot in the same diagram. You have one more like this. So A, B, C, D, E, F, G, H. Now we have the values. So this is tau xy distribution, shear stress distribution. Let us see what are the values of shear stress at those 8 points. At A and B it is 0. 0 here, 0 here. At C, its value, at C also it is 0, D also 0, F also 0, correct? Yellow 0. So at C also it is 0, D also it is 0. E also 0. F value 3F by 2D value. Shear force now. How to show shear force? This is not tau xy, but its value is 3F by 2D. What is its value at C and B? It is 0. That means here at F its value is more, So 3F by 2D. That 3F by 2D, what I will do here is, here it is 0 of course. Here it has got some value. This value is 3F by 2D. 3F by 2D. And also at H also it is 3F by 2D. Here also it is 3F by 2D. The thing is, it is 0 here, it is 0 here, and the variation is parabola. Parabola variation. It varies with respect to y in the parabolic manner. That means it will be like this. Like this. But this will be acting like this. Shear stress normal stress hige. But since it is 2-dimensional, we have to show like this only. 3D diagram badale torskodu alva. So shear stress is perpendicular to normal stress irutte. Shear stress will be perpendicular to normal stress, but here since this is a 2-dimensional diagram, we can show only like this. So this is acting like this. This is acting. And on this you don't have any shear stress. See, you don't have any shear stress at AEB and also at CGD. So shear stress is 0. In other words, tau xy is equal to 0 on AB and CD planes. And what? Illi shear stress illa, illi shear stress illa, illi maatra irtade. So this is the shear stress. So this is how we have to show the sketch. Like this. That completes the problem. Doubt idea? Curve is out. Parabola. Illi 0 alla. Illi 0. Illi value 0. Parabola ivaga ಇನ್ನೊಂದು ಪಾಯಿಂಟ್ ಕರೆಕ್ಟ್ ಅಂದ್ರೆ ಹೇಗೆ ಬರುತ್ತೆ parabola convex ಇದು parabola here also it is parabola. Actually you can write in 2 types. ಹಿಂಗೂ ಬರೀಬಹುದು, ಹೀಗೂ ಬರೀಬಹುದು. ಬಟ್ ಇಲ್ಲಿ ಇನ್ಕ್ರೀಸ್ ಆಗಿರೋದ್ರಿಂದ ಹೀಗೆ ತೋರಿಸ್ತೀವಿ ಕಾನ್ವೆಕ್ಸ್. ಬಟ್ ಅದೆಲ್ಲ ತುಂಬ ಏನು ಡೀಟೇಲ್ ಆಗಿ ನೋಡೋಲ್ಲ. ನಿಮಗೆ ಮೇಯ್ನ್ ಆಗಿ ಹೌ ಇಟ್ ವೇರೀಸ್ ಆನ್ ಇಂಪಾರ್ಟೆಂಟ್. ಲೀನಿಯರಾ ಅಥವಾ ಕ್ವಾಡ್ರಾಟಿಕ್ ಅಂದರೆ ಪ್ಯಾರಾಬೋಲಾ ಅಥವಾ ಏನೋ ಕರ್ವಾ ಎಕ್ಸ್ ಇಂಟು ವೈನ, ವೆದರ್ ಯು ನೋ ಹೌ ಟು ಪ್ಲಾಟ್ ಇಟ್ ಅಂತ. ಅದು ಗೊತ್ತಿದ್ರೆ ಆಯ್ತು. ಸೊ ನಮ್ಮ ಸೆಂಟ್ರಲ್ ಪಾಯಿಂಟ್ ಮಿಡ್ ಪಾಯಿಂಟ್ಸ್ ಯಾಕೆ ಬೇಕಂದ್ರೆ ಸಮಟೈಮ್ಸ್ ಇಲ್ಲೊಂದು ವ್ಯಾಲ್ಯೂ ಇರುತ್ತೆ ನೋಡಿ, ಈ ವ್ಯಾಲ್ಯೂ ಬರ್ಕೊಳ್ತೀಗ ಇಲ್ಲಿ 0 ಇರುತ್ತೆ, ಬಟ್ ಇಲ್ಲಿ 0 ಇಲ್ಲ. ಅದೇ ಥ್ರೂ ಔಟ್ ದಿ ಪ್ಲೇನ್ ಇಟ್ ಇಸ್ ನಾಟ್ 0. ದಟ್ ಈಸ್ ವೈ ವಿ ಹ್ಯಾವ್ ಟು ಕ್ಯಾಲ್ಕುಲೇಟ್ ದಿ ಮಿಡ್ ಪಾಯಿಂಟ್ ಆಲ್ಸೋ. ಅದಕ್ಕೋಸ್ಕರ ಮಾಡಬೇಕು ಮಿಡ್ ಪಾಯಿಂಟಲ್ಲಿ. ಸೊ ಸಮಟೈಮ್ಸ್ ಇಟ್ ಇಸ್ ಲೈಕ್ ಸ್ಟ್ರೆಸ್ ಡಿಸ್ಟ್ರಿಬ್ಯೂಷನ್ ವೇರೀಸ್ ಫ್ರಮ್ ಪಾಯಿಂಟ್ ಟು ಪಾಯಿಂಟ್. ದಟ್ ಈಸ್ ದಿ ಮೇನ್ ಕಾನ್ಸೆಪ್ಟ್ ಇನ್ elasticity. Whereas in strength of materials, we assume stress as constant over entire area. P by ಅಂತ ತಗೊಂಡ್ಬಿಡ್ತೀವಿ ನಾವು. Force divided by area is stress ಅಂತ. ಸೊ ಅದು ಎಷ್ಟೇ ಏರಿಯಾ ಇರಲಿ, we take uniform stress. But here it is not like that. Stress varies from point to point. So that is why when a structure is loaded at a critical point, stresses will be more at that point. ಅಲ್ಲೇ ಫೇಲ್ ಆಗೋದು ಸ್ಟ್ರಕ್ಚರ್. ಅದಕ್ಕೆ ಇದು ಬೇಕು. ಫ್ರ್ಯಾಕ್ಚರ್ ಮೆಕ್ಯಾನಿಕ್ಸ್ ಇಸ್ ನೆಕ್ಸ್ಟ್ ಪಾರ್ಟ್ ಆಫ್ ಥಿಯರಿ ಆಫ್ ಎಲಾಸ್ಟಿಸಿಟಿ. ಮೈನ್ಯೂಟಲ್ಲಿ. ಸೊ ಸ್ಟೀಲ್ ಕನೆಕ್ಷನ್ಸಲ್ಲಿ ಫೇಲ್ ಆಗ್ತದೆ. ಸ್ಟೀಲ್ ಸ್ಟ್ರಕ್ಚರ್ಸು ಬೋಲ್ಟೆಡ್ ವೆಲ್ಡೆಡ್ ಆ ಪಾರ್ಟಲ್ಲಿ ಫೇಲ್ ಆಗ್ತದೆ ಯಾವಾಗಲೂ. ಕಾಂಕ್ರೀಟಲ್ಲಿ ಫೇಲ್ ಆಗ್ತದೆ. ಬೀಮ್ ಕಾಲಮ್ ಜಾಯಿಂಟ್ಸ್ ಇರುತ್ತಲ್ಲ ಅಲ್ಲಿ ಫೇಲ್ ಆಗ್ತದೆ ಕಾಂಕ್ರೀಟ್ ಸ್ಟ್ರಕ್ಚರ್ಸು. ಯಾಕೆ ಅಂದರೆ ಸ್ಟ್ರೆಸ್ ಜಾಸ್ತಿ ಇರುತ್ತೆ. ಸೊ ವೆರೆವರ್ ಯು ಹ್ಯಾವ್ ಮೋರ್ ಸ್ಟ್ರೆಸ್, ದಿ ಸ್ಟ್ರಕ್ಚರ್ ವಿಲ್ ಫೇಲ್ ಅಟ್ ದಟ್ ಪರ್ಟಿಕ್ಯುಲರ್ ಸೆಕ್ಷನ್. ದಟ್ ಈಸ್ ವೈ ದೀಸ್ ಆರ್ ಇಂಪಾರ್ಟೆಂಟ್. ಸೊ ನಿಮಗೆ ಸ್ಟ್ರೆಸ್ ಕಾಂಟ್ರೋಲ್ಸು ಕೂಡ ಕೊಟ್ಬಿಡುತ್ತೆ ಇದರಲ್ಲಿ ಸಾಫ್ಟ್ವೇರಲ್ಲಿ. ವೆದರ್ ಯು ಆರ್ ಯೂಸಿಂಗ್ ಇ ಟ್ಯಾಬ್ ಆರ್ ಸ್ಟ್ಯಾಡ್ ಪ್ರೋ ವಾಟ್ ಎವರ್ ದಿ ಸಾಫ್ಟ್ವೇರ್, ಇಫ್ ಯು ಆಸ್ಕ್ ಫಾರ್ ಸ್ಟ್ರೆಸ್ ಕಾನ್ಸಂಟ್ರೇಷನ್, it gives the where the stress is maximum and what is its value, all those things it will give. But mathematically, analytically, you can calculate manually like this. So that is why only basic concepts you are learning here. We cannot analyze complex structures manually. Softwares will do that. But how? We have to read it. So if they give a stress diagram, you should be in a position to tell whether it is tensile stress or compressive stress or shear stress. Like that, it should be in a position to tell. So for that, some functions are given, stress functions are given, and you are asked to plot the stress distribution. So this question has appeared in 2 question papers for 10 marks. Practice ಮಾಡಿದ್ರೆ ಮಾಡ್ಬೋದು. Within 15 minutes you can complete this. Okay.